Okay, hello there and welcome to Scientific Python part number 1. And the agenda of the class is going to be, start from basics, right? Only when our basics are correct will we be able to write professional programs and scientific data analytics programs and all those machine learning and artificial intelligence programs. So what we have decided that we'll go for a complete course wherein we are going to understand each and everything separately. Like we are going to start with NumPy, which is numerical Python. Basically, num means numerical and py means Python, right? And then we are going to take pandas. Then we are going to take matplotlib separately and complete it, and then we are going to take seaborn and see its functionalities and all the visualizations, right? And then we are going to go with statistics in machine learning, and then we'll go to the regression part, linear, logistic, k-means, clustering, and slowly we'll understand all the logic behind the machine learning, right? And predictions, right? And to quickly get started, let me introduce you guys to part number 1, that is NumPy. And what is NumPy? I'll have to explain it. Now you can go through this. Take a note while learning. Okay. Now you can see NumPy is a Python package which stands for numerical Python. Right? It is a core library for scientific computing which contains powerful and means multi-dimensional array objects provide tools for generating C, C++, etc. It also useful linear algebra, random number capabilities, and many different things. I'll tell you, NumPy is basically an array which we use, right, and that consumes less memory. NumPy is very fast, it's very convenient, right, and it gives us luxury of doing many different things that we are going to learn today. Now, in short, it comprises or consists of multi-dimensional array objects and a collection of, we can say, routines for processing those arrays. We have arrays and then we have to follow certain routines for processing those arrays. Let's quickly get started with, let me call that as Anaconda Jupiter. Right, so I'll open my Jupyter notebook and I'll immediately go with a new file. All right, you can see here Python 3. So we are handling it using Python 3.0. Right, so now I will save this file. I'll say save as numpy1. So numpy class 1 is going to be here. Now let us immediately go. What you can do is, if you are using Jupyter Notebook separately or you are using Python ideally, so what I suggest you to go to command prompt, right, and do pip install numpy, right? Okay, I have done something wrong. So it is numpy. You can do a pip install of numpy, right? Requirements already satisfied. And now, in case if you are using Anaconda, you can go to Anaconda prompt, right, and say a pip install, right, numpy, right? So numpy, numeric Python. Right, now, in case if you have downloaded and installed Anaconda, packages like NumPy, matplotlib, and pandas come pre-installed with Anaconda, right? So in case you have, let me assume that you've already downloaded and it's already working. I'll go with import. Right, so let me just zoom in a bit so that you can see the happenings with your own eyes. import, right? Now the visibility is good, I suppose, so I can say import numpy as np. Now what is this np? Np is just an alias that we are giving to numpy, or you can say nickname for numpy or an alias for numpy, right? I'll immediately say run. Now then we have run, right? I'll go to the next line and I will show you the demonstration of first a single dimensional array and then a multi-dimensional array, right? So let's start with a single dimensional array, and I call this as n1 as a single dimensional array, right? I'll say n1 will be assigned, so this is an assignment operator which works from right hand side to left hand side. Whatever is on the right hand side will be assigned to left hand side. I'll call np, which is an alias for numpy dot array. Now we are not making a normal array, we are making numpy array. Alright, so now numpy takes array as a list. Now that's the feature of NumPy. It takes array as a list because we have to do many different things like sorting, and we'll have to see that whether NumPy arrays are mutable or immutable. They are mutable, right? So I can say numpy.array and single dimensional. So let me call this 10, 20, 30, 40, 50, right? And I'll say process, and after processing I'll go and print the NumPy array. Now you can see it's a single dimensional array, right, which has 10, 20, 30, 40 and 50. Now you can say, right, I want n1 dot, just like in pandas, alright, so you can call this, no, it's not panda, sorry, you can call n1 dot 0th element and you will get 10. If I call n1 dot first element, you will get 20, so long and so forth, right? So this is how it works. Alright, and let me show you how do you create a multi-dimensional array. Now we have a multi-dimensional array. That means we have to supply two lists, but yeah, first we are going to have a list which is a single dimensional array list like this. Now you can see we have those square braces. Now to define a multi-dimensional array, you have to go inside this square braces and create two arrays like this, right? And in between two arrays we are going to have comma, so that this is the dimension 1 and this is going to be dimension 1 and this is dimension of the main array. So for example, let me do this. I'll say 10, 20, 30, 40, right? And second array may have let's say about let me call this as 40, 30, 20, 10. Alright, so now let me immediately run it. So I'll say n1, and I can easily see that we have a multi-dimensional array, right? So if I go with dimension 0 this time, it's going to show me a complete array instead of, what I did here was something like this. Alright, if you say no, we have to basically call it something else. So let me call this n2 and let me call this n2 here. Right, so now if I say n1.0, so at 0th dimension this array has 10, but at 0th dimension this array has another array right here. So this is the difference between a single dimensional array and a multi-dimensional array. Or you can, if you want this 10, you can say go to dimension 0 of n2 and give me the 0th element, so which is 10, or go to the first dimension, which is this first dimension, right, and give me the 0th element, which is going to be 40 in our case. So let me expand it for you. Alright, basics are going to be pretty important here. Alright, so let me expand it. Alright, so let me expand this np.array so that you understand it like a pro. Right, so let me create it big enough so that we guys can easily understand it. So this is what we are focused on. Alright, so this is the main dimension, alright, and this is the first dimension, right? So now if I say what is this area from this area to this area, this is going to be the first dimension, and this area to this area is going to be the second dimension. So we know that arrays start from 0, so this is going to be 0 of n2 and this is going to be 1 of n2. Now if I say 0 of n2, it's going to return complete element. Now what is inside the 0 of n2? Another 0, right? So it's going to be 0 of n2 and 0th element, first element, second element, third element, right? And it is going to be the 0th of first element, 0th of first element, and then first of first, second of first, and third of first, right? So it works like this, right? Alright, so let's carry on. Now we've understood what a single dimensional array is and what a multi-dimensional array is, right? So array is collection of lot many things rather than a variable being collection of a single thing, right? So now we are done. I'll say I need n2. Now we can see n2 is a multi-dimensional array, right? And as I said, NumPy array is powerful n-dimensional array object which is in the form of rows and columns. Now that's the best thing about NumPy array. It's in the form of rows and columns, and we can initialize NumPy array from nested Pythonlets and access its elements. In order to perform these NumPy operations, so we'll have to understand what is the NumPy array and what is the list. As I told you that list is Python array, and NumPy is NumPy array here, right? So that's what we are doing is, and it is comparatively more faster than and more or less memory consuming than Python, right? So this is an example of single dimensional array. Let me basically insert a cell above, and I say single dimensional array. So let me say I want to view not the header, I want to view the toolbar, and I'll say this is going to be the markdown. So I'll say double hash, or it's going to be the heading, right? So it is going to be single okay, let me not call this as heading. So let me call this as markdown, or maybe okay, let me have this right here. So this is going to be a markdown for you. So I'll say single dimensional array. Now this is the markdown, right? You can clearly see. And here we move to this area. So I will say insert a cell below, and I'll say multi-dimensional array, and I'll make it as markdown. So this is the markdown of multi-dimensional array. Fine, then we are done with the multi-dimensional and single-dimensional arrays. Okay, and let's carry on with a few more things right here. Right, and if I show you, for example, if I make this n is equivalent to list, so I'll say 10, 20, 30, right? So now this is n, and I will say type of n, please give me the type of n. So we're getting list, right? So now if I say I need type of n1, now what is the type of n1 here? So that is my question. Now you can say it is numpy n array, right? What is nd array, right? It is the n times, or we can say a numeric, right? Okay, now you can clearly see that it's numpy.array. Alright, so multi-dimensional is checked and single dimensional is already tell. So now let's say if I want to initialize my array with zeros automatically, alright, so does NumPy provide anything for that? Right, I can say right, n1, which is the NumPy array 1, is equivalent to np dot 0, right? And I'll give columns and rows. Now you can see what will happen here is ni is equivalent to n1. What is expected? I did not close it here, right? Fine. So let me go ahead and print n1. You can see that it has been initialized with zeros, right? You can clearly see this right here. Fine. And this is the number of rows, and this is the number of columns that you want. So now we have only one here, so that is why it's initialized by zeros. Let me show you something else. So if I say np.zeros 5 and 5, so what is going to happen in that point? So 0, 1, 2, 3, 4 means 5. So we have 5 zeros here. 1, 2, 3, 4, 5. So 5 in rows and 5 in columns. So let me say 2. Now you can see we are having only, right, we can say either 2 rows and 5 columns, right? So this is how it works. 5, 5, right? You can see we have initialized all the zeros with, or the complete array with 0. So this is something that we use for machine learning. NumPy is, if I tell you about predictions, if you have to use machine learning algorithms like TensorFlow is there, when we have to pass, predictions, right? We have to make predictions, and there are layers, right? We have to pass the decision of first layer to the second layer, and then so on. So NumPy is going to be very handful there. So you'll learn that inshallah. Right, so we have seen dot zeros. How do we initialize, the array with zeros, right? What if I want to initialize all the array with, let's say about the full array with same numbers, right? So I'll say import. Now import is already done, so I will say n1, which is NumPy, assigning to np, which is the alias for NumPy. So I will say full. Full means fill. 2 and 2. So we are going to fill, we are going to have 2 rows and 2 columns. And what are you going to do? So I am going to apply this full, right, which takes the first parameter, number of rows and number of columns, and second is going to be what do you want to fill with, right? So I say fill my NumPy array with 10, but where? Where do you want 10 to be, or where do you want that 10 to appear? I will say I want that 10 to appear both in rows and 2 columns, right? So now if I run it and I say N1, you can say 10 has been filled, right? The array has been filled with 10, 10, both at the row point and as the column point, right? So initializing NumPy array with the range. So let me say, now how do I initialize? So let me document it. I just forget documenting it. So I'll say insert a cell above, right? So we've seen this here, initialize with zeros, and here is initializing NumPy with same number is what is going to be our markdown. Okay, what is this seam? It is same number, so I'll just copy and paste it, right? So initializing NumPy with same number, and I'll have another markdown here, and I will say initializing NumPy array with let me call this as with a range. We already know range in Python, alright, so we'll be using that range again. So I'll say N1 is equal to NP. It's not range basically, it's basically a range with a range, alright. So I'm going to define ranges for normal Python program. So here we use a range, right, and I can say 10 and 20, right? So this is what my a range is telling me, and let me print an a or n1. Let me print n1. What has happened? Just a moment. A range, so I didn't say a range, so n1 is equal to np.a r a n g e. Right, now you can see 10 to 20, 10, 11, 12, 13, 14, 15, 20 is going to be the maximum, right? It's going to go till 20, means 20 is not going to print, right? So because it's going to be 1. If you want to print till 20, then you'll have to say 21, right? So it's going to always be less than, alright? So this is how we use a range, right? Not range here, so I have to use a range. Range will throw error here, so we have to use a range here in NumPy to declare an array with this kind of a thing, right? Or what we can do is, for example, if I want NumPy to skip my number, so I can say here skip, right? So I can say skip, right, numbers, right? So I can just go ahead and I say n1 is equal to np.a range. That's absolutely fine. Go till 10, go 10 to 50, but skip each, while iterating through, skip 5, right? Means you're going to get 15 and then you're going to get 20, just like that. So you're skipping 5. Like you say, after 10, you're skipping 5, going to 50, skipping 5, going to 20, 25, and then this is how you can skip. So a range has taken the third parameter, is like that you have to skip certain things. So this is very useful in machine learning. You'll come to know, but yeah, remember what is happening forever and ever and ever. That's why I come back to basics, right? To clear your basics, right? So at least we'll have something at our hand. If I complete NumPy, so I'll say, okay, now I'm done with NumPy. Okay, now let's say pandas is remaining. So now, and then once I complete pandas, then I say, no, only matplot is remaining. So when the going gets tough, the tough get going, right? So to win, you have to begin. Right, so in order to win, we need to begin. So we're beginning with this, and I even thought it would be better if we could start with basics, right? In order to win, we need to be very, very much sure about basics, and we need our basics to be clear, and we need to know the happenings and do's and don'ts, right? And where the push and pull of data is happening, we need to know each and everything of it, right? Okay, now this is skip numbers. Now what if I want to initialize NumPy array let's say I want to initialize. Initialize is INitializing. Okay, so I had misspelled it. Initializing Numpy array with let me say, now we will see with the random numbers, right? So initializing Numpy array with random number. So I will just initializing, I'll just change the spelling here because it's everywhere. Initializing mistakes. Okay, fine. So now it's done. Alright, so let me carry on with this. So initializing Numpy array with random numbers. Now if I want to initialize with random numbers, I'll say n1 is equivalent to numpy, which is np.random. So we can call this random function, right? And we can pass the random numbers to a numpy array, right? And I can say rand random integer. So that's randint, which is the random integer, starting from 1 to 100, right? So I can say print n1. So now we can say we have 50. So I'll say okay, just a moment. We have to go and get an array first. n1 is equivalent to np.random randint, right? And yeah, I have to apply the skippable values. That is, I want to skip 1. So now you can say array has this 65. Now if I say 5, skippable is 5. Now you can see you're skipping 5 now, right? After 1 you are having you're skipping till 100 and you're skipping 5. Oh my god. So let me say 100. Okay, you're going with random numbers, right? And you can say that I have 5. Not skipping, it's not skip here. Rand takes third parameter as number of parameters, right? Yeah, number of numbers, no, number of elements, sorry. I'm still with this skip number, sorry. It's random numbers. So it's going to be the number of, elements that you want to create, right? Okay, number of rows, or yeah, number of rows. So if I say 10, it's going to be random numbers in all 10 rows, right? Skippable is not going to happen because you are initializing random numbers here, right? So all cells are going to have different random numbers. If I say 100 cells, so they're all going to have different numbers, right? So you can see here, so they're all going to have random numbers. So this is how it works, right? Random numbers, and you can say, yeah, checking the shape of numpy array. So let me create a markdown. So checking the shape of numpy arrays. So for example, I have np, we can say n1 is equivalent to numpy dot array. Now I'm creating a multi-dimensional array, and we create it like this, and in between it has a comma, 1 2 3, and then I can create 4 5 6. Now if I need to know the shape of this array, right, and for that I can say n1 dot shape. What is the shape of my array? Okay, n1. So now it has 2, we can say the shape is basically, it is 2, and every single cell has 3 values, right? So for example, if I increase now, so it is going to become 3, right? So I'll say 7 8 9. So now you can say it will be 3 by 3. All right. So we have 3 elements, and each element has 3, data. Each element has, now if I say this, now you can say 3, and this is unknown, right? Because one has 2, another has 3, so it needs to be actually same, right? All have to be same. Then and only then you will get. Now if you'll see, you will get 2 into 3. 2 comma 3 should be the result. Yeah, 3 comma 2, right? So we have 3 dimensions, and every dimension has 2 values, right? So this is how shape works, and we can change the shape as well. For example, you can see the shape is just like this. But let me 3 and 4, right? So let me have this here, 5 6 7 and 8. Right, let me have 9, 10, 11 and 12. So let me have shape is 4, 4, every single cell has 4, and total number of dimensions are 3, 1, 2 and 3. Yeah, exactly. Now if I want to change, all right, it is 3 by 4. I want to change. I'll say n1 dot shape is equivalent to, now I change it, I go with 4 comma 3. Now you can see you're changing the shape of multidimensional array. If I say n1, or if I go here and say n1 dot shape, now you can see the shape is completely changed. Here it was 3 4 and here it is 4 3. Or you can even say I need to print n1. Right, now you can see 1 2 3, it was just like this earlier, or let's say without or before shape. Let me compare it, before shape and after shape. So let me print it here and 1. Alright, so let me go ahead here, and now you can see this is 1 2 3 4 5 6 7 8 9 10 11 12. 1 2 3 4 5 6 7 8 9 10 11 12. That's perfectly alright, but they are 3 dimensions here. 1 2 3 dimension. Now what I said, I need 4 dimensions, so it has automatically taken it to 4 dimensions. 1 2 3 4. If I say 2 now, so now if I say I need only 2 numbers in 1 dimension, right, and now then it's going to be 1 2 3 4 5 6 7 8 9 10 11 12. So just like that, so on and so forth, right? So this is how we basically change the shape and get the shape. Yeah, why do we get the shape? At times we may have to change the shape because data analytics depends on how well balanced, how well arranged the data is, right? And it is only the arranged data that we can do artificial intelligence predictions to, right? Not only data analytics, that you should be well aware of these techniques, before starting with machine learning also, right? Because machine learning, data analytics, we always deal with numerical values, right? Alright, then now shape is done. So now can we add, so I'll say addition of Numpy arrays. So let me mark this as markdown. So now can we do addition of Numpy arrays? Yes, why not? Let me see that if n1 is equivalent to np.array, and let me pass a single dimension 10 and 20. Alright, and I will say n2 is equivalent to let's say about 30 and 40. Alright, so we have 2 arrays. Alright, now I can say, right, np, which is numpy alias dot sum. I can call sum and I pass 2 parameters, n1 and n2. Now you can see here, no, something is wrong. What is wrong here? Okay, let me execute this. Yeah, this is absolutely fine. And then I can say np dot sum, or we can say n3 is equivalent to np dot sum. What? Yeah, it is going to create an error here because you have to supply axes. Means what are you adding? Are you adding like this 10 and 20 and then 30 and 40? What is the axes? Now I will supply axes. axis axes is equivalent to 0. So now the moment I say axis is equivalent to 0, it's still not doing it right. Just a moment. N1 is equivalent to np.array this, and I can say np.sum numpy.sum n1 and n2 on axis 0 and or axis 1 still. Sum got multiple values for argument axis. Why do we have axis is equal to 1? Yeah, sorry, my mistake. So I'm not adding like arrays. Sorry, my mistake. I'll say n3 is equivalent to np.sum because we are adding 2 arrays and I forgot that we are adding 2 arrays. So I'll say n1 as an array, you have to supply it in list, and I'll say n2. Now you can see it has successfully completed. Now if I print n3, the array sum is 100, right? 40, 50, 70, 80, 90 and 100. It has by default added all. right? Both arrays have been added, right? So now if I do not want that, so I'll say n3 is equal to np dot sum, right? So I will say n1 and n2, but I need it to be axes, columns or rows. So I'll say axes is equal to 0, and I can print the axes. Now you can say that we have on axis 0 we are getting 40 and we are getting 60. So axis 0 means you are doing 10 plus 20 is equal to 30. That is axis 1. You're doing it on, right? You can see clearly right here that what it is doing, right? It's adding these two numbers right here. 30 plus 10, 40, 40 plus 20, 60. Right? Understand? So these are going to be right on rows and columns. Wait a second. Alright, so it has added. So now we know that they are now XC0 means you're adding columns here. 10 plus 30, 40, you're adding columns, right? 20 plus 40, 60. Now what if I want to add rows? So 0 means add columns, right? And I can say now I can add rows as well, right? ROWS. Now I'm adding rows, right? And I'll say for that axis is equal to 1. And if I print n3 now, right now you can clearly see right now it has added rows. Now you can see 20 plus 30, 20 plus 10 is equal to 30, and 30 plus 40 is equal to 70. Now such a beautiful feature, you won't believe. We've already shown you previously in Panda's videos that we do this axis 0 and axis 1, right? But it's very wonderful, it's beautiful, right? And imagine you applying this using multi-dimensional array and getting results like this, right? So axis 0 is columns and axis 1 is rows. And this was the sum, addition of Numpy arrays, right? And we can see multiplication as well. We'll see that inshallah, right? And now we have joining. So let me call this as joining Numpy arrays, and it's going to be a markdown. Control enter. So now we have joining Numpy arrays. For example, n1 is equal to np dot array, and I'm going to supply array here, which is a Numpy array 10, 20, 30. Alright, so I'll say now n2 is equal to 40, 50, 60, whatever it is. Right, so now we have two. What if I say I have to join them? Alright, so now we have n1 and n2. Now if I say that I need to join those arrays, now how do you join? Alright, so what is the process of joining? Now for the process of joining says we have, just like this, we have vstack, vstack, right, which means vertical joined, and we have h stack means horizontal join, right? And we have column stack, right? COLUMN underscore stack column join. So this is how we join Numpy arrays. We have vstack. Alright, so let me see vstack now. Alright, so this is an example of hash vstack. So let me see vstack here. Right, I'll go ahead and I'll say np dot vertical stack, right, and I will pass both of the Numpy arrays, and here you have to pass within square braces, right, because whenever you stack up you have to pass within these braces. If I pass it like this, n1 and n2, now you see we are not getting, so we are expecting something. Okay, so I forgot it. Now it's still doing the same. What it has done, it has joined them vertically. Even if I use these braces, yet it is going to show the same. There's not going to be too much of difference. So let me stick to this array. Okay, now what it has done, 10, 20, 30, 40, 50, 60 has been vertically joined. You can see that first this and now this. So vertical means this. right, row-wise join, right? Not column-wise join, it's row-wise join. And let us see now, at stack, horizontal stack, and to check the horizontal stack, I'll use the same array, and I'll make sure that we call, okay, let me call at stack, horizontal stack here. Now you can see, right, it has joined them horizontally, right, in a single line. 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60. And this is how the vertical stack works, and this is how the horizontal stack will work for you, right? And this is, now let us check column stack as well. Why wouldn't COLUMN? So let us check column stack as well. Why would you remain behind? So for that, I will call COLUMN underscore column stack. Now stack up. Now you can see clearly it has done column stack, right? 2 columns, right? You can clearly see, right, and 2 and 3, right? So you can see this is how it works with column stack. So 10 and 20 are taken in single column, right? And then we can say, right, so this is how it has done. But how it has done is basically created 3 dimensions right here. So if I say now np dot column stack, so I'll say n3 is equal to this np, so I can say n3, right? So I can get n3 like this, or I can say n3 0th element, I'm getting 10 and 20, 10 and 40. Now you can see 10 and 40, right? And if I say give me the first element, I'll get 20 and 50, right? If I say give me the third element, so I'll get no, it's only 2, right? So 30 and 60. So this is how the column stack is going to work for you. So let me just get rid of this and see that column stack, right? Alright, so now column stack is done. Alright, so now line space. So let me tell you what line space is, right? Right, another Python operation, another Python, I'll say numpy operation, right, which returns evenly spaced numbers, and certainly which returns evenly spaced NUMBERS, which returns evenly spaced numbers over a specified interval, right? So it's INTERVAL. So it's much better definition, right? So example, so I can say example is below, so I'll take this as heading maybe. So heading is going to be too big for us, right? No, I don't want to take it as heading, I want to take it as markdown, so let it be. So lines SPACE, line space, another Python numpy operation which turns evenly spaced numbers over a specified I do a lot of spelling mistake interval, and the example is right here. So if I say A is equal to numpy dot line space, right? So I'll say A is equal to numpy dot line space, and I say 1, 3 and 10. Now let me show you, right? So what is this going to do? NP, okay, LINE. No, it's not line, it's LIN, line. Lin space basically, it's not line. Why did I say line? LIN, lin space, right? So it's lin space, right? So if I say lin space and then if I say A, now you can clearly see that what it has done, right? Clearly see, right? It has created amount of evenly, right? As I said, evenly spaced numbers over a specified interval, right? Now you can clearly see here the result has printed 10 values between 1 to 3. So it has printed 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 values, and those values are between 1 and 3, right? Now you can see those values between 1 and 3, 1 dot, 1.222, 1.444, 6667, and they are evenly poised, right? You can clearly see, that's what I said. They will return spaced numbers. So now you can see all the spaces are here. They're not covered, right? Evenly spaced numbers. All right, so it's going to be again a random number. Another yeah, interval is also there. All right, so it is going to be understood. You'll understand it once we move to some higher operations. But yeah, it's good to remember that what len space will do. And we have max, min, right? And we have this max and min operation in Numpy. Let me see this maximum and minimum operation, right? So I'll say A is equivalent to np dot array. I'll create a single dimensional array, for example 1, 2 and 3. All right, I'll go ahead and say A dot minimum. What is A dot minimum? What is A dot maximum? Right? What is A dot sum? Right? You can see all three things at the same time. Okay, I have to print them separately. I was going to print the last one, right? Okay, let me use print min, and I will say print A dot min, which is the minimum value in the array, right? And I can simultaneously print the maximum, and simultaneously I can go ahead and print the sum of total numbers available and min also. Now you can see the minimum is 1 in this array, right? And the maximum, okay, it's not maximum, it is again minimum. Okay, the minimum is 1 and the maximum is 3, and the sum total is 3 plus 2, 5 plus 1, 6. So the sum is 6 right here. So this is how we can use minimum, maximum and sum in a Numpy array, right? Alright, so operations may get a bit complex, but you'll at least understand. Maybe I'm doing A dot min of one array with 2 dimensions and then calling the 4th dimension, but at least you'll come to know that what is the basic core behind this, the core logic behind this numpys, right? It's basically, you must be finding these pretty basics, but with the help of this knowledge you can perform a lot bigger task as well, right? Let's say what is axes in Python. So let me give you let's understand what is axes in Python first. All right, so let me tell you. Now you know that this is y axis and this is x axis, so I don't have to tell you this, right? So this is called as this is called as x-axis, and this is called as y-axis. And maximum machine learning algorithms, they depend on the deviation, right, which is happening around x and y. If I say what is tan theta, in 10th class it used to look something greater, but nothing. Tan theta is how much impact will be on y when x changes. If x changes, how much y will change. That's all what tan theta is all about. We learn that in the future once we take statistics and mathematics. But yeah, you have to understand this is x is 0. Why do I say that this is x is 0 and x is 1? So now what is x is 0? Now once we are moving along x-axis, we call this as x is 0. Once we are moving along y-axis, we call this as x is 1. So now that's why I said x is 1 is rows, because you are moving like this, right? And x is 0 columns, right? Like this, right? We can say a Numpy array, has rows, and those rows are called axes 1, as I already told you, right? And the columns are known as axes 0. So let me show you some basic example of standard deviation and square root. For example, if I use A is equivalent to np dot array, right? And let me use a multi-dimensional array this time, and let us say 1, 2, 3, and I'll say 4, 5 and 6. Now if I what happened? 1, 2, 3, 4, 5, 6. A is equal to NP dot array 1, 2, 3. Okay, now what am I doing here? Okay, I didn't pass the basic array element here. Yeah, sorry, my mistake. And now if I print A, you can see it's a normal multidimensional array. But if I say print, I need you to print np.sqrt. I need the square root of A, right? Complete square root of A. Now you can see you're getting the square root of, all the elements. This is 1 square root, right? You can even see that second dimension, right? So you can clearly see the square root, or you can even say I need you to print me the standard deviation, right? And if you don't know standard deviation, I'll give the rough about standard deviation, std. For standard deviation, I go and pass A. Now standard deviation is 1.70 on the axis, right? Let me give the rough about standard deviation. And let me take a look at the timings first before I move with standard deviation. It's already 45. Okay, let me take standard deviation for 5 minutes. So now what is standard deviation? Right? Standard deviation is basically, for example, if I give you, if I give you test, for example, right? I am taking your test or exam, right? And I'll draw a line here, right? And this line is going to be your exam, for example. It's still statistics question, so I'm not interested in teaching you right that, but yeah, since if it is it, so let me take it. So now let's say about we have around 50% females and 50% males, right? And I can take it like this, right? And take it like this, and maybe like this, or maybe like this. So now I don't have the proper scale right here. Now you can see how much the center point is. For example, if I say that everybody is passing the examinations, we would expect that most of the students which would achieve about average, with fewer achieving with high or very low marks, right? Some may achieve high marks, some may achieve low, and maximum are going to be in between low and high on average. So this can be displayed on a graph, right? We call it as normal distribution curve, right? And now what is the normal distribution curve? So if I call this as low score, right? So this is basically, right? So now let's call this as low score. I'm defining standard deviation here, and if it is high score, right? So statistics, topic number 1, that is standard deviation, and this is going to be the score on test. So let's say this is going to be some score 10, 20, 30 and minus or whatever it is. So you can say this is some score on test, right? So let me call this some score over the test, right? And this is from this side it's high score, and this side there's low score. So now we may have some students who may start moving like this. Okay, let me take a pencil, right? So now we may have this score. Okay, let me take it like this, and let me take the blue arc. We may have this arc going like this, right? And then we may have this again coming down. So this is people who have scored high, and as we move along, and they can see the average area. So this is going to be the average marks area, right? Okay, let me make you understand. So this is mean score on the test right here. So this is here, all right? So this is mean score on the test, all right? So this is mean, which is mean. So this is the mean here, mean score on the test. Now let us say, so what does the standard deviation mean here, right? So let's say about it is a measure of dispersion right here, whatever dispersion is taking place. It measures how spread out the data is from the mean, and from the mean score, how much data is spread out, right? The more students, the more data is going to be spreaded, right? And the further the data spreads, the greater the standard deviation. The more the data spreads, the greater is the standard deviation. The standard deviation of 0 indicates all values in the set are same right here. But for example, if I tell you, it defines how close this mean, this is the mean, so it defines how close the mean is right here, right? How close the mean is, right? So I'll say, or we can say how close the mean, or we can say the standard deviation describe how close to the mean the individual scores are, right? So that means individual scores, how many are basically close to this mean. Now you can see if someone has scored, for example, if it is 100, right, and this is 90, right, or we can say from this side. Okay, let me go for this side. For example, it's 100, and this is 90, and this is 80, 70, 60, and now you can see 50%, right? 50, and then we'll go on with this 40, 30, 20, 10. So like you can see, if I now make score, if I make my standard deviation graph of 1 points, so it's going to be more spread out, right? But still I'm making 10 points here. So right, so now what does it indicate, right? Mean score means 50%. How many are closer from this side? How many are close towards the losing side or towards the failing side? How many are close to this mean score right here, and how many are close to this mean scale? So standard deviation is that basically, how close the mean, right, or we can say how close the mean is to the individual score, right, or how close individual scores are to the mean, right? If standard deviation is very small, let me take this like this. If this is standard deviation, and if this standard deviation is quite small, now you can see this, it has smaller and it's going up now, right? So the most students have achieved close to the average score, right? So most are going close to the average score, right? And if the standard deviation is not low, right, or the standard deviation is not small, right, if it is large, then the student scores are very spread out from the mean, right? That means individuals achieving either high or low, not average. Either we have many maximum students achieving high and low, right? What I want the mean score. I want this to be shrunk like this, right? So it means more students are close to this, right? So we want the closely, or we can say we want small spread, standard deviation here. But yeah, if the standard deviation is large spread, we have passing, or we have, just like in India, we either have rich or we have poor, because the rich have taken all the money of poor, right? So the standard deviation is basically impossible when it is rich versus poor, because it's going to be just like this. Standard deviation is going to be this. So this is rich and this is poor. So standard deviation is not possible here. But yeah, I want everyone to be closer. So what I want as an organization, if I'm having a school or a college, I want this to be small rather than largely spread it out, right? Or for example, if I say another thing. So for example, if I say this is going to be again standard deviation, and this is girls, and this is girls, and this is boys, right? High to low, right? I want all equal. If I have to check whether girls and boys are getting the equal education and trainings in my school, so I want boys and girls to be equally close to mean score. Let's say about, if girls are not closer to mean score, and boys are more closer, means boys are studying good, learning good, or they are being provided good education, and girls are not. So that's what I mean by standard deviation. Because the standard deviation is much bigger for boys. If it is, the scores are far more spread out than 50%, right? And if it is closer to girls from the other side, that means they are having plus 50% on the test. And the summary is that standard deviation measures the spread of data from mean. So this is mean, so it is going to measure the spread of data from mean, right? If the standard deviation is large, right, and we can say participant scores are far away from the mean. If the standard deviation is small, participant scores are close to the mean. What I want my organization to have a mean score, or we can say standard deviation, close to the mean. So that is how close the standard deviation is. It's doing comparison between these two arrays, right, and checking out the standard deviation, which is happening at 1.7 right here. I'll give you, once we take statistics on, I'll give you more rough explanation of standard deviation. And by the way, it's not our topic today. We're still at NumPy. Let's try and close NumPy. And let me take a look at the time today. Right, we still have 5 minutes, so we have to close it up in 5 minutes. I hope you understood standard deviation. This is how we take out standard deviation. Now, is there any other way of adding two arrays? Yeah, we can add. There are many ways. For example, if I say x-axis, I am having on x-axis np.array. Alright, and let me say, what is nm? I don't understand. Okay, np.array, I will say, okay, we have a multi-dimensional array, right? Multi-dimensional is like this, and I say 1, 2, 3, and I say 4, 5, 6, 1, 2, 3, 4, 5, 6, or whatever it is. So this is x-axis, and let me call this as a y-axis. Now if I say print x plus y, sorry, right? So you can perform more operations on NumPy, that is addition, subtraction, multiplication, and division of two matrices, right? Because they are matrices here. So let me go ahead and print this for you, and I get an error as expected. List indicates must be integer, not slices, not a tuple. Where is tuple? Okay, we are printing x plus y. And let me see what is wrong here. Okay, I am at it, so let me clear. Yeah, we still have this error, right? I don't know. np.array, right? So we have this single. Okay, I didn't. Okay, no comma. How can I do this? So let me print x and y. Now we are going to get, right? You can easily see that we are done plus 2. All right, so it's go 1 plus 1, 2, 2 plus 2, 4. And 3 plus 3, 6, and 4 plus 4, 8, 5 plus 5, 10, 6 plus 6, 12. And what else can we perform, right? I can say minus. I can perform subtraction. 1 minus 1, 0, 2 minus 2, yeah, it's expected. I can perform multiplication, right? 1, 1, 1, right? 2 into 2, 4, 3 into 3, 9, 4 into 4, 16, 5, 5, 25, 6 into 6, 30. 6. And what else can we perform? We can perform divide, right? So we can perform modulus to give us the remainder, right? Quotient, remainder, whatever you say, you can perform each and every mathematical operation right here. So now the question is, we can say NP arrays, that's NumPy arrays, mutable. Are they mutable? And for that, I'll mark down, right? And here is the answer for you. So if I say A is equivalent to, I want to initialize NP. How do you initialize with zeros? .zeros. I'm initializing NumPy array with zeros with 3, 3. And I say I want A. Now what is wrong here? Okay, I do this every time. I don't know. Why do I do this? Okay. Now you can see you have initialized 3 column, 3 rows NumPy array. All are having zeros. Now if I do, now see this what I do. C is equivalent to A. Right. Now if I say C, you are getting the same array. But what if I say C? Please change the 0th position on the 0th row and take it 1. Right, now if I do this, right, execute it, and now C has changed. Is it going to impact A? Let me see that. If I print A, yes, it has impacted the 0th row. The 0th position has taken 1, which means arrays are mutable. NumPy arrays are completely mutable here. So I'll see you guys on video number 2. Right, so do practice very hard, and do have to basically watch and go through the video 2-3 times unless you're aware of what we have learned. Alright, so I shall be sharing the sketch, a PDF sketch, and you can find the sketch down in the description section, and you can download it pretty easily. Right, and till then, Till the next video, do practice very hard and let me know down in the comment section if I can help you. And as promised, we are going to complete NumPy, then go to next topic, then go to next topic, complete all, then wind them up together, join them together to perform machine learning operations. And I wish you all the best. See you, do pray for me, and bye-bye, take care.